All right, so now that we know generally what an arc length is all about, let's talk about how we come up with the fraction or the portion of the circle that matters to us given an example. Here in number 1, we can see a diameter has been drawn, and I care about the fraction of the circle that's on the right-hand side here, and we know that this diameter will give us a 180-degree arc measure. So to determine what percentage or what the fraction of that circle is that I care about, I take that 180 degrees, the portion that matters, divide it by 360. It's kind of like what of the circle, what of the whole circle is in play here. When I do this in my calculator, it's just 180 divided by 360. Math, enter, enter. And every time I do that, which we've done many times, I know, it will give you the formal fraction. In this case, it's 1/2. Oops, my little number 1 went away there. All right, let's take a look at this next one. They've given us a 90-degree angle. And in this case, let's talk about this portion of the circle, what we don't know. Okay, given a 90-degree central angle, of course, we're going to have a 90-degree arc measure. But I care about the rest of the story. So I need to take the total circle, subtract 90 from it. I come up with 270 degrees. So the portion that I care about is going to be, or the fraction of the whole thing will be that arc measure divided by 360. And when you do that in your calculator, you'll come up with 3/4. That makes sense. You know, you can see that if you were to cut this into 4 equal pieces, this is 1/4 of it. The rest of it's 3/4. But just to make sure we all understand how we came up with it. Finally, I have this circle. I've got this piece that matters to me. They've given us a central angle of 150, so I know that the arc measure will be 150 as well. So the fraction of the circle that I care about, that I have highlighted, will be 150 divided by 360, or 150 of the whole thing, or of 360. So let's take a look at that in the calculator. I'm going to do 150 divided by 360, and straight to math, enter, enter. And I come up with a fraction of 5/12, or wait a minute, what was that? 5/12, yeah, okay. So this is not as simple to determine. It is important to know that this is the process you would use to determine which portion of the circle matters to you. So let's talk about what the formal formula is for arc length of a circle. The length of the arc, remember, just the straight line distance, for lack of a better term, the distance a little bug might just crawl all the way from here to here. We call that, it's going to be equal to the arc measure, which I'm going to just show abbreviations if you prefer. Okay, arc measure divided by 360 multiplied by the circumference, which we know to be c above. Go ahead and pause the video, make sure you have all that written down, and then come back. All right, so given the information above, we want to determine the arc length of each of those circles, and we're going to use the formula to do so. I'm going to write the formula again. And again, I've got arc divided by 360, arc measure divided by 360 times the circumference. Now keep in mind, our formula sheet, as we saw above, will give us the circumference as either 2 pi r or pi d. In my case here, I've been given the radius, so I could actually just rewrite this with the actual circumference formula, which is 2 pi r. So as we did in the beginning of the class, we're going to just straight up erase replace. In this case, everything we need on the right-hand side is given to us. So we can just put that information in. 180 divided by 360. Again, that was the fraction of the circle that we care about. And then we multiply it by the circumference. In this case, it would be by 5. It would be the radius that's important that I'm going to input. So let me go to the calculator, make sure we all see how this looks. This is multiplied. So we don't necessarily need, it's all multiplication. It's a very forgiving means, but just for giggles, let's go ahead and make it look just like what we wrote down. So 180 divided by 360 times 2. times, again, the pi is that second caret, brings up my pi, times 5. And when I do the math, you can see that this value with a decimal point, oops, is 15.7. So we'll just write 15.7, round it to the tenths place. This radius was measured in units of inches, and so now my arc length is also in units of inches. Let's take a quick step backwards though, and let's do this by using or finding it in what we like to call in terms of pi. We looked at that a bit above. So I'm going to take that same information, 180 divided by 360. Okay, I got that from over here. I'm going to multiply this by 2 and then by 5, but I'm going to not include the pi. Okay, when I not include the pi, I'm just going to show that figure I come up with here, the mathematical figure, and then just throw a pi right next to it. It feels and looks the same exact way. So multiply that by 2 times 5, again leaving the pi out this time, and look at how pretty that number is. Nice number at this point. It's straight 5. So to show this in terms of pi, we would simply say 5 pi inches. And that's legal. In fact, that's the way the SOL is going to want it to look in some cases. When I take that 5, again, all just the numbers dumped in there, and multiply it by pi, okay, again, caret, second caret, I come back to what I came up with initially. So it's just a matter of you guys using whichever method you want. The answer choices they're going to give you, sometimes they're going to look like 5 pi. Sometimes they're going to look like 15.7. And the good thing is, it's just like with a radical situation. You have the means and the methods with your calculator to determine which one it is. You just have to put the information back in. All right, so given what we did on number 1, go ahead and try number 2, and number 3. Go ahead and pause the video and then check your work, and we'll go from there. All right, and you should have gotten that on number 2, 56.5 meters, or in terms of pi, it would be 18 pi. Again, multiply the 18 and the pi, and you'd come back to 56.5. And then for 3, 7.9. If you have any issues, or if you didn't get those answers, please raise your hand and we'll give you some help. All right, let's turn to the back of the page. So what is the area of circles, and what is the formula? So again, I've given the standard formula over here that you'll see when you get to the SOL. The area is the measure of the surface space inside the circle. It's kind of like if you think about, in fact, let me go here, take a crayon, and we'll make a green crayon. And if I were to highlight everything on the inside, like the surface area in square inches or square units, in this case square feet, I've given some examples, or square meters, that's how we measure it. It's the surface space. And the formula we're going to use is right here. The area is always equal to pi r squared. So we've got this formula for us on the formula sheet that we'll have on the SOL. In example number 1, it says find the area of circle if d is equal to 4. So I start with always writing the area formula, a equals pi r squared. In this case, my diameter is given to me, so recall that the diameter is equal to 2 times the radius. In this case, the diameter is 4, and so I need to divide both sides by 2 to come up with the fact that my radius is 2. Now hopefully you just knew what to do there. So now it's a matter of just sort of plugging and chugging, right? Little erase replace. So pi, my r, I come up with is 2. And if I put this in terms of pi, without using anything relating to my calculator, I'm just going to leave the pi by himself, sort of drag him back to the next step, and do 2 squared, which is 4. So I've got the area is equal to 4 pi. And of course, if you do that in the calculator to come up with the actual number, okay, it would end up being 12.6. And we don't have a dimension, so we would just say units squared. Okay. All right, and the second example here, it says find the diameter of a circle if the area is equal to 34 pi. So here is kind of back what we were doing on our sheet before, where we always start with the formula, Always, always start with the formula. Write that darn thing down as many times as you need to in order to determine what to do. I'm looking for the diameter here, and in my formula I can find my radius, which of course then we can come back and find the diameter. But I need to input the information given. The A was 34 pi, so I need to just erase replace. It just happens to be on the left-hand side today, is equal to pi r squared. So what do I do now? I need to get the pi by himself, and if this pi, just going back to some of our other units, was something like 2. Let's say that was a 2 pi r squared. I would divide both sides by 2. Well, here it's a pi. And what does that matter? Is this a variable? No, it's a number. It's 3.14, etc., etc. So I can just divide both sides of my equation by pi. And just like when our numbers cancel out, right, the 2 and the 2, if that was 2, these guys go away. In fact, because this is legally just 34 times pi, I can get rid of the 2 pi's over on this side. And that's a helpful transition as I go down to the next step, because now I'm going to move the r squared to this side and set it equal to 34. Now it's just a matter of doing the square root of both sides to get my happy little r by himself, and I end up with r is equal to 5.8, and again we're back into just straight up units because I don't have any specific dimensions. All right, so that's important. We're going back and forth, and throughout the SOL, sometimes you're going to straight up ask you for the area of something or the circumference of something, and sometimes you have to backtrack. So let's talk about the sector. What is the sector of a circle? The sector is the region bounded by 2 radii and their intercepted arc. Go ahead and pause the video and input that information and then come back. So just like we had in our arc length, when we talk about sector, it is the portion or the area of the portion of a circle. Okay, we call this the sector. The area of the sector is the fractional part of the circle's entire area. Okay, and generally it'll be shown this way. They may also, in a word problem, convey the fact that they're looking for the area of a garden or something like that. But that's what they're looking for. So what does this look like? Let's talk back about our fractional components. Again, we've just pretty much done this before. Here, the shaded area has a 126-degree arc measure. And so we're back to arc measure, and we need that portion or that piece in order to determine what the fraction of the circle is that matters to me. And when I do this in my calculator, I've got 7/20ths of the circle that is shaded in this case. Over here, I've been given a 97-degree arc measure. So again, I've got to take that 97 away so that I can figure out what matters to me, because this is the arc measure I want. I want this guy, the big arc. And so when I do 360 minus 97, I come up with 263. And now I'm back to, okay, well then what's the fraction that is shaded? It's 263 degrees of the total, which is 360. And that's equal to, frankly, this doesn't reduce. This is a gnarly reduction. We're just back to exactly where we started, but we don't care. It's still legal. That's still the pure fraction of the circle that matters to me. And finally, in this case, I'm looking for just this portion. They've given me 340 from here all the way around to here is what they're trying to say there. So I need to do 360 minus 340. And when I do that, I get 20. So this is a 20-degree arc measure. 20 divided by 360 is my fraction. In this case, it turns into 1/8 of the circle that is shaded. So let's take a look at the formula for sector, and then you guys can do some examples. What is the formula for the area of a sector of a circle? Well, it's very similar to our arc length. Okay, we've got area of the sector, and I might write it as A of the S, or SEC, however we want to do it to designate that that's what we care about, is equal to the arc measure divided by 360. And here we don't even actually say area or put it in words. There's only one formula for the area of a circle, and it is pi r squared. So we are essentially multiplying the area by the fraction that we like, that we care about, that matters to us in each problem. And we find that fraction by using the information we already know with arc measure. So let's see how this looks in some examples. Just using the information from above, we've got the, let's see here, we've got a radius of 4.5 miles. So I'm going to, oops, sorry about that. I'm going to do r is equal to 4 point, actually, let me do this over here. Get rid of that. R is equal to 4.5. And the area of the sector is equal to arc divided by 360 divided by pi, I'm sorry, multiplied by pi r squared. And I'm just going to substitute. So my arc measure above was 126 divided by 360 times pi times r squared. And I just put in parentheses because I'm a math geek and sometimes I just kind of do that. But because this is all multiplication, it's very forgiving. You don't have to worry too much about it. So let's clear up our screen and let's do this in the calculator, see what it looks like. 126 divided by 360 times, and we're going to give it as a decimal, times pi times 4.5. And hit the x squared button. That's the easiest way to do this, okay? You won't get yourself jacked up if you press the wrong button at this point. So the area of this sector is 22, where was my calculator? All right, 22.3 is where that would round to. Excuse me, I don't know what's going on when I'm transferring between the two. So 22.3, let's make it prettier. All right, and then remember we like to see these in terms of pi sometimes, so let's see what that looks like. I'm going to do 126 divided by 360. So again, we're going to multiply everything except the pi. So it's going to be that fraction multiplied by 4.5 x squared, which gives me 7.1. And so the number in terms of pi would be 7.1 pi. Not as pretty as the stuff we saw above in arc length. So probably the SOL would just give it to you in these units. By the way, these are in miles. So this is a pretty big component. And then remember, we're in miles squared because we're doing the area. All right, so go ahead and pause the video. Do number 2 and number 3 using the same formulas and check your work and make sure you got the same thing. And make sure that you do it in terms of pi too. Let's make sure we check our work both ways. All right, and you should have gotten those values for 2, 146.9 meters squared or 46.8 pi meters squared, same thing. And for 3, 1.6 centimeters squared or 0.5 pi centimeters squared. If you didn't get those two things, raise your hand and we'll give you some help.